Assalamualaikum dan salam sejahtera. So for today we are entering our final chapter, chapter 4. And in this chapter we are discussing about positive displacement pump. Okay. So this topic is important because pump is a device that we use to increase velocity of fluid or to transfer fluid from a low level to the higher level. Okay, previously in our lesson, especially in fluid mechanics 1 and fluid mechanics 2, you already know about pump, but that type of pump is centrifugal pump. Jadi kalau kita buat imbas semula, sebab tu kita belajar dalam fluid 1 dan fluid 2, kita memang ada belajar tentang pump, tetapi pump yang kita belajar di situ adalah centrifugal. Okay, centrifugal pump. Okay, centrifugal pump memang mempunyai reka bentuk yang mudah. Dia mudah difabricate lah, mudah dibina, dan dia merupakan common pump yang digunakan dalam kehidupan seharian. Tetapi di dalam tajuk ini, saya ingin membawa pelajar untuk melihat ruang lingkup yang lebih luas berkenaan dengan tajuk pump. Kerana tidak semua keadaan kita boleh menggunakan centrifugal pump. Dan ada pelbagai keadaan yang mana centrifugal pump adalah pilihan terakhir atau mungkin tidak boleh digunakan dalam keadaan tersebut. Jadi maksudnya awak dapat idea bahawa pump bukan setakat centrifugal pump sahaja, kita ada pelbagai jenis pump. Okay, so this is the introduction. I think this note is already uploaded to my website. So first, we just make a revision about what is pump. Pump is a machine used to move liquid through a piping system and to raise the pressure of the liquid. So here, I would like you to know that pump has two major function. One is to move liquid. So means that if you want to have a higher speed of your liquid, so you could use a pump to increase the speed. So or you want to transfer your liquid from the lower level to the higher level, so you can use pump to do so. So here dia mengatakan untuk meningkatkan meningkatkan tekanan, so to raise the pressure. So salah satu maksud untuk meningkatkan pressure ialah membolehkan air untuk pergi ke tempat yang lebih tinggi. Okay, yang tu. So kerana awak tahu kalau air pipe tu dia tinggi, kita boleh mengira pressure dia dengan rho GH. Oleh itu tekanan dia adalah tinggi. So berkenaan dengan move liquid ini, okay, yang saya maksudkan ialah contohnya awak masih lagi contohnya awak ada tangki dan awak ingin basuh kereta contohnya. So mungkin air pipe awak rendah, jadi apa awak buat, mungkin awak masukkan dalam pump, so air boleh keluar dengan agak laju. Okay, itu konsep yang digunakan sebagai water jet. So maknanya kalau awak nak bersihkan rumah, bersihkan sesuatu dengan water jet, so kita tidak berkehendak untuk mengangkat air ke tempat yang lebih tinggi, tetapi kita hanya berkehendak supaya air bergerak dalam keadaan laju. Okay. So kemudian yang ini saya rasa awak baca awak pun boleh faham why increase a liquid pressure. So static elevation, a liquid pressure must be increased to raise liquid from on elevation to a higher elevation. So ni saya rasa awak pun faham. Friction, it is necessary to increase the pressure of liquid to move the liquid through a piping system and overcome frictional losses. So kadang-kala kita dapati bahawa major loss, minor loss yang ada di dalam sistem pipe adalah besar. Oleh itu kita perlu memberikan extra energy. So pump juga dikenali sebagai satu device yang memberi extra energy kepada aliran. Ia terbalik dengan turbine. Turbine adalah satu device yang menyerap tenaga daripada aliran air. So kemudian kita berkenaan dengan pressure is to move liquid into a pressurized vessel such as a boiler or fractionating tower. So maksudnya kita nak mewujudkan satu keadaan supaya ada cecair ataupun gas yang bertekanan tinggi. And then velocity, usually velocity of the liquid leaving the pump is higher than that entering the pump. Okay, yang ini saya rasa bawa faham, maksudnya kita memerlukan aliran had laju yang tinggi. Okay, so yang ini yang saya harap awak mula faham bahawa two common classification of pump. Satu dikenali sebagai rotodynamic pump dan satu adalah positive displacement. Okay, cuma di dalam fluid mekanik 1 dan 2, kita yang sebenarnya hanya pergi kepada rotodynamic dan kita spesifikkan lagi jenis pump tersebut adalah centrifugal pump. Okay, so apa yang dikatakan rotodynamic or kinetic pump? Is a rotodynamic pump, energy is continuously added to the liquid to increase its velocity. When the liquid velocity is subsequently reduced, this produces a pressure increase, and the common example of this type of pump is a centrifugal pump. So rotodynamic is as shown in its name, so means it has a rotation motion, and dynamics mean it rotates continuously. So means that the energy is continuously added to the liquid. So that's why if we see centrifugal pumps here, we have blade. Okay, we have blade like that. Okay, and then blade will rotate at certain speed. Water will enter the casing, and the kinetic energy from the blade, because blade is rotated by a motor. Okay, so we have a motor here. So motor will rotate the blades. So mean the kinetic energy from the motor is now transferred to the blade. Then when the water comes into the casing, so the kinetic energy is transferred to the liquid. Then this liquid will have an extra energy. So with this extra energy, so liquid could move faster, could flow faster, or liquid could travel to the higher level. So dia ada extra energy, dia boleh bergerak laju, maksudnya dia convertkan tenaga tersebut terhadap tenaga kinetik diri dia. Air akan bergerak laju, atau air akan menggunakan tenaga tersebut untuk potential energy, untuk berpindah ataupun untuk mengalir ke tempat yang lebih tinggi. That is the meaning of increase its and to the liquid to increase its velocity. So this term is reflect the idea of kinetic energy that transferred from the motor to the liquid, and then an extra energy in the liquid is now could transfer into the potential energy or to the kinetic energy of the fluid itself. Okay, so the common one is centrifugal. So okay. So kemudian kita ada lagi satu, we have another type of pump which called positive displacement pump. Okay, this might be your first time to heard about this, but I think it is quite simple. In a positive displacement pump, energy is periodically added to the liquid by the direct application of a force to one or more movable volume of liquid. So this is the keyword. This causes an increase in pressure up to the value required to move the liquid through ports in the discharge line. Okay, first, you need to understand that positive displacement, so the energy transferred to the liquid is not continuously. It is periodically. So it will transfer at certain time only. So it will repeat itself. Okay, so and then the idea of positive displacement, okay, so you could understand with the word of displacement here. So it reflects the meaning of volume. So means that for positive displacement pump, we transfer liquid by its volume, not by transferring kinetic energy from one device to another, to the liquid. So jadi positive displacement, awak kena faham, dia sesuai dengan namanya, positive displacement. Positif melambangkan dia akan bergerak ke atas. Okay. Displacement adalah sesaran, dia melambangkan tentang isi padu air yang disesarkan. Oleh itu, positive displacement, pump ialah sebuah pump yang akan mengalirkan air, tetapi idea utamanya ialah dia memindahkan air secara volumetrik. Maknanya dia memindahkan air secara isi padu. Maknanya dia akan tolak 1 liter, 1 liter, 1 liter sehinggalah air sampai ke destinasi yang diperlukan. Okay. Contoh paling mudah berkenaan dengan positive displacement pump, so the simple example of positive displacement pump is your picagari. Awak punya picagari lah. So mean you could suck water, katakan medicine, and then you could be awak boleh transfer dia ke tempat yang lain. Jadi proses picagari untuk sedut tu adalah proses di mana kita menyedut air, and the energy or the fluid will only transfer when you push that water to the discharge line. Okay, jadi awak boleh imagine kalau picagari itu awak gunakan untuk memindahkan air. So, waktu awak tarik picagari, air akan masuk. So, maksudnya tidak ada aliran keluar. Bila awak tolak picagari, barulah air dialirkan keluar. That's the meaning of energy is periodically added to the liquid. So, antara contoh, another mechanical example for the positive displacement pump is the pump for well. Okay, for example, we have a perigi here. Okay, so awak tahu. So and then some people normally, okay, so the water level is at the bottom. So awak pun, ni saya silap tulis. Okay, sikit. So let's say we have a well here. So and then the water level is quite low. So what people do is people do not install a centrifugal pump inside this well. Okay, normally people will use positive displacement. Okay, so we have a long pipe here, and then we have a pump here with a jack, with a handle like this. I think you could imagine this one. So when you move this handle up and down, so it starts to suck water here, and finally the water will come out. And you could imagine that the water will not come out all the time like centrifugal, because in centrifugal pump, energy is continually added, so means that the water could flow continuously. But for this positive displacement pump, the energy is periodically added, so means the water will come out periodically. So means every time you push, you pull down the lever down here, so the water will come out. Then when you pull up the lever, so it start to suck water again, and then when you pull it down, so the water will comes out again. So means the water will comes out periodically. Okay, boleh faham So itu yang dimaksudkan dengan positive displacement pump. Pump ataupun sebuah device yang digunakan untuk mengangkat air, mengalirkan air, tetapi dia akan bergerak secara berkala. Okay, so this is the overall distribution of pumps type. So normally we have pumps here. So and then it can be divided into two major groups, which is kinetic or rotodynamic and positive displacement. So what is kinetic? Because the energy is transferred using the transfer is in term of kinetic energy. So means you rotate your blade, and then kinetic energy from the blades transfer the energy to the liquid, and then liquid could move faster or liquid could flow to the upper to the higher level. Okay, and positive displacement is not about the kinetic energy, it is about the displacement, the volume of water. So, and then for kinetic pumps, okay, normally we are using centrifugal pump. So, because this is the common pumps, and then we already have all of this. So, and then for positive displacement pump here, okay, yes, if you see here, so we have a rotary pump and also reciprocating pump. Okay, so the rotary pumps, okay, you may imagine that the word rotary here means it has some kind of blade here and it will rotate at certain speed. Okay, here you may think that this will use kinetic energy to transfer the liquid. No, the answer is no. So yes, it has a rotating part, but the idea to transfer the liquid is not from the kinetic energy. It still use the idea of volumetric, mean to transfer liquid in terms of volume. Okay, we will see this type of pump later on. Okay. So, and then our focus in our topics in our chapter 4 here is actually about the reciprocating pump. So reciprocating pump also it's as I say it's like a pichagari. So so you have a pump like this. Okay, another name for positive displacement reciprocating pump is a piston pump. So you have a piston and piston will move forward and backward to pump the liquid. Okay, another name for reciprocating. So reciprocating means the motion is in linear, because if you, I think you already know the reciprocate motion. So the reciprocating pumps mean the piston here is only move in linear direction. So it will move forward and backward to pump the liquid. Okay, so we will discuss about the reciprocating pumps here, but I hope you could have time, you could spend your times to search the different and the similarity of these two types of pump. But the idea, the basic idea, I will explain later. Okay, so now we are focusing about the positive displacement pump. So it is one of the earliest decisions that must be made in designing a system, and applying a pump is the selection of type of pump to be used, whether the pump should be of the centrifugal or the positive displacement type. Okay, the first thing that you need to do when you start to decide to use a pump is to know whether you could use centrifugal pump or you should use another type of pump. Okay, so another type is usually the positive displacement. Means that you need to think whether you need to put an extra energy on the liquid by kinetic energy, or you need to transfer it by volume. Okay, major selection of pump is centrifugal because of its reliability and lower maintenance. So this is the advantage of centrifugal pump, because if you have chance to look inside the centrifugal pump, you could Google it, you could see it in YouTube. It is found that you may find that centrifugal pump is very simple device. You just need a motor and you just need to create your own blade, whether it is radial, backward or forward, any kind of blade type. So you already know about the blade shape, forward, backward, radial. Okay, normally people just use radial because it's easy to fabricate. If you have chance to open your aquarium pump, your fish aquarium pump, you could see that the blade is radial actually. So yes, in terms of efficiency and so on and so forth, it might be not so efficient, but it still can transfer water about 3 to 5 meters high. So means it will give you a very high speed of water in terms of conducting a koi pond or do your aquarium, your aquarium cycle. Okay, so it's and then it's very low maintenance. Okay, because it's easy to clean it and so on and so forth. You may disassemble your the blade and so on, and then you could fix it again, and then the pump will rotate like usual. Okay, so the idea is centrifugal pump usually have fewer moving part, have no check valve, associate with the pump, produce minimal pressure pulsation, do not have rubbing contact with the pump motor, and not subjected to the fatigue loading of bearing and steel. So please remember this term, because I will not explain it now, because you don't see any type of positive displacement, but please refer back to this statement when I show you a few examples of positive displacement pump, because you could see that in positive displacement pump, they will have a valve there, and then they will have a rubbing contacts. So, and then it will, when you have a lot of rubbing contact and so on and so forth, so it start to have a fatigue loading. Okay, that's the disadvantage of positive displacement. Okay, but positive displacement will have another advantage that will not have, that you will not get in centrifugal pump. Okay, then, but centrifugal pumps are not always to the application. That you must know that we have a lot of engineering application, and centrifugal pump cannot solve all that problems. Sometimes, for sure, we need to choose positive displacement. Okay, now we would like to see the advantage of positive displacement. Okay, when to choose a positive displacement pump. Positive displacement pump have the ability to pump viscous liquid. So first advantage of positive displacement pump is it can pump a viscous liquid. So mean if your liquid has high viscosity, okay, you need to use a positive displacement to flow that liquid. So for example, you are handling toothpaste, ubat gigi, kilang ubat gigi. Kilang ubat gigi dia tidak akan gunakan centrifugal pump. Kerana awak pun boleh imagine, kalau ubat gigi kita sedut masuk, kita masukkan di dalam centrifugal pump, apabila blade berpusing, kita dapati bahawa mungkin sedikit ubat gigi yang akan ditolak keluar, tetapi akhirnya ubat gigi akan maintain dalam bentuk bulatan saja. Tengah tu pump. Okay, awak pun boleh imagine kita ada blade berpusing. So dia berpusing macam itu, tapi ubat gigi akan duduk di luar je. Ubat gigi tidak akan mengalir masuk. Okay, awak boleh nampak. So maknanya centrifugal pump will totally cannot be used. Okay. So in centrifugal pump, it is possible to handle low viscosity liquid. However, pump efficiency degrades rapidly as viscosity increase. There is an upper limit of viscosity above which is become impractical to consider centrifugal pump due to excessive waste of energy. For high viscosity liquid, some type of positive displacement pump may be the only practical solution. So maksudnya di dalam keadaan high viscosity liquid, so 100% awak terpaksa gunakan positive displacement pump. Okay, so kemudian antara lain ialah major advantage of positive displacement pump is most positive displacement pump types are inherently self-priming. So awak kena ingat perkataan self-priming ni. Okay, means they can be located above the surface of the liquid being pumped without the necessity of the suction line being filled with liquid and the non-condensable gases in the suction line being removed before starting the pump. Okay, dia ada dua idea. Pertama, the main idea is self-priming. Okay, self-priming ni untuk kita overcome dia ialah dengan cara memasukkan air di dalam suction line. atau kita kena buangkan gas yang tersimpan di dalam suction line. Okay. So these terms, okay, this statement is telling you about this. Okay, let's say you have a well here, ada perigi. So and then the water level is here. So you will find that if you want to use centrifugal pump, it is okay because in well, okay, dalam perigi it consists water. Okay. So but the first thing that you need to do is you need to put your centrifugal pump inside this water. That is the correct way to use centrifugal pump. You must make sure that in not using mode and use mode, maknanya dalam keadaan awak gunakan pump atau tidak, centrifugal pump mesti terendam di dalam air. Kerana why centrifugal pump needs to being submerged in water? Because blade need to contact with water continuously to make sure that the water that it could transfer the energy continuously. Okay, orang akan letak centrifugal pump di dalam perigi. So the problem is you may have a wire, a very hard, long wire like that, and so on and so forth. So people will not use centrifugal pump in this case. So, okay. Why? Because if you transfer, for example, you put your centrifugal pump outside the well. So mean now your centrifugal pump is not submerged in water. So what happen is if you switch on the centrifugal pump here, the blade will rotate, but centrifugal pump not capable to suck water from the well here to the blade. Okay, because this is the disadvantage of disadvantage of centrifugal pump. Okay, because it cannot create a vacuum condition. Okay, so this is okay. Let's say for the same well here. Okay, so you have a water here. That's why people will use positive displacement pump. Okay, you use PD because PD could create a vacuum condition, and then it could suck water from this level. So because it transfer water by the idea of volume, so means that every time you push and pull the lever here, so it will suck, it will transfer this water with a certain volume time by time. So dia akan sedut sedikit, naik sikit, naik sikit, naik sikit, naik sikit, dan akhirnya air boleh keluar. That's why kalau awak imagine ada pump untuk perigi yang macam gini, saya rasa awak boleh nampak kan. So awak selalunya awak kena tekan lama-lama dulu baru air keluar. Okay. Contohnya yang paling mudah, mungkin perigi, mungkin di luar awak mungkin susah nak jumpa. Idea yang paling mudah ialah pump minyak tanah. Okay, kalau pump minyak tanah, kita nak sedut minyak tanah daripada tangki. So apa yang perlu awak buat ialah awak akan goyangkan pump minyak tanah macam gitu kan. Lebih kurang dia keluar macam gini, dia ada sedut, kat sini dia ada pemegang kan. Awak akan tarik ke atas ke bawah. So awak akan tarik pemegang tersebut ke atas ke bawah. So bukanlah maknanya awak start tarik je air terus keluar, tidak. So awak akan tarik lama, mungkin 2-3 second baru air keluar. So apa yang berlaku dalam 2-3 second tersebut ialah dia sedang menyedut air. Okay. So dia menyedut air, lepas 2-3 saat barulah ia akan keluar. Dan kalau awak tengok air yang keluar tu pun secara berkala. Itu yang dikatakan periodically transferred. So maknanya ketika awak tarik air keluar, ketika awak tarik mungkin air tak keluar, ketika awak tekan air akan keluar. Okay. So yang dikatakan self-priming ialah, okay, yang dikatakan self-priming is the ability of pump to suck water or to pull water from its level to the higher level. Maknanya kebolehan dia untuk menyedot air sedikit-sedikit, untuk menarik air sedikit demi sedikit sehinggalah ke outlet, Itu yang dinamakan self priming. Okay, so self priming maksudnya dia boleh menggerakkan air itu sendiri tanpa bantuan. Okay, berbeza. Okay, so it is totally different with centrifugal pump. If you put your centrifugal pump outside the water, here for example, so what you need to do is you need to, with necessity suction line being filled with liquid. So what is mean by filled with liquid? If you still want to use centrifugal pump here, what you need to do is you need to do some kind of reverse flow first. So awak kena masukkan air. You fill a water from the outlet of your centrifugal pump here, and make sure that the water will fill the centrifugal pump, and then fill the suction line here. Then you could on the centrifugal pump. Then the water fill in the line here will suck the water continuously into the pump again. So maknanya self priming tu awak kena, centrifugal pump dia tak boleh buat primering tu sendiri. Awak yang kena tolong buatkan. So caranya ialah awak masukkan air secara reverse flow, maknanya masukkan air daripada output, daripada discharge pipe sampai penuh, and then awak run pump. So baru pump boleh berpusing dan barulah dia akan continuously. Okay, kerana dia boleh membentuk siphon. Yang ni awak faham lah. Kita dah belajar dalam fluid 1, fluid 2, kenapa air boleh bergerak kalau dia dah, awak dah penuhkan suction pipe tu dengan air. Okay, so maknanya awak kena buat sendiri priming tu instead of pump itu yang sendiri buat. Okay, maksud self priming di sini ialah positive displacement, awak tak perlu nak masukkan air dalam outlet, so awak boleh tekan, air boleh naik sendiri. Okay, atau ini kalau sekiranya awak menggunakan awak dah try buat tak boleh, so mungkin awak kena buka sikit, kasih udara yang gas yang tersimpan di dalamnya dibebaskan semula. Kadang-kadang air tak boleh nak mengalir di dalam positive displacement di dalam centrifugal pump kerana kita kata ada udara yang tersekat. Okay. So dalam masalah ini juga, antara kelebihan positive displacement ialah positive displacement ia boleh menyimpan air. Contohnya awak ada pump, positive displacement pump here. Okay, for the first time, yes, you need some time to make sure that water will suck into the suction line here. So after that, when you stop using this pump, this positive displacement pump, water will remain inside this suction line. Okay, normally, okay, in certain positive displacement pump, it can be remain there. And then next time when you want to use the positive displacement, then the water is ready to be flow out. So it's different with centrifugal pump. For example, you already already done your self priming here. You fill the water and the pump run continuously. Then when you stop the pump, the water will flow out, and the suction line here will be empty again. And then next time when you want to use centrifugal pump, you need to do the you need to prime it again. Okay, that. So another advantage of positive displacement pump is positive displacement pump could create high pressure at low flow, which is impossible to be created by centrifugal pumps. So this means that positive displacement pump can transfer water to the higher level, far higher, very high compared to the centrifugal pump. So the graph about the head of pump can be shown in this graph. So you could see here the reciprocating here. So the line is like this. So means that it could reach around 100,000 head pounds square inch, okay, PSI, compare with the centrifugal pump with just only 6,500. So the 6,500 and 100,000 plus is totally relatively high in terms of value. So rotary here is another type of positive displacement pump, but it's still not cannot beat the reciprocating pump. That's why I would like we will focus on reciprocating pumps here, because sometimes maybe you need to use reciprocating pump to solve your problems. However, for reciprocating pump, you cannot run it in higher speed, because they will lead you to the cavitation problems, or the slip, the volumetric efficiency will reduce so much. So we'll learn about the efficiency later on. Okay, and then if you could see that centrifugal could run is around 200,000 plus in terms of speed, mean gallon per meter, gallon per minute. So mean the flow rate is quite high, but it cannot transfer water into to the higher level. Okay, that is the pro and cons of centrifugal pump and reciprocating pump. So if energy efficiency were the only consideration, so if you just think about the energy itself, so positive displacement pumps would be considered. However, another factor such as install cost and maintenance expense often outweigh the energy saving. So this means that if we compare the energy efficiency of positive displacement pump and centrifugal pump, so for sure positive displacement pump has good energy efficiency, but normally engineers will say that positive displacement pump need more maintenance cost. So that's why centrifugal pump will become the first choice for many problems. So and then positive displacement pumps are good in pumping liquid containing solid such as sewage water. So this is I think you already know, if you have a solid, so mean a particle in your liquid, so people will not use centrifugal pump. Okay, contohnya kalau ada air yang bercampur dengan bahan buangan, so indah water atau sebagainya, indah water tidak akan menggunakan centrifugal pump. Itu sebab kalau awak tengok lori indah water, kalau awak pernah tengok macam mana dia sedut, awak akan nampak air tu disedut secara berkala di dalam pipe dia. So maknanya kalau ada lori kat sini, ni lori indah water tu, okay, dia akan ada pipe kat sini. Okay, kalau awak pun boleh imagine lah, dalam cerita movie ke mungkin nampak kartun ke, so awak akan nampak air yang disedut kat sini, dia akan menyebabkan pipe kat sini bergelombang. Okay. Bergelombang tu maksudnya dia sedut lah, zup dia sedut. Kenapa dia sedut tu? Kerana periodically dia suck that water. So maknanya kalau dia gunakan kalau dia gunakan positive centrifugal pump, dia akan smooth kerana air akan bergerak dengan kadar alih yang sama. Okay, so boleh nampak so itu. Masalahnya kalau paling mudah kita nak kaitkan dengan projek ikan koi awak, selalunya kalau awak projek ikan koi, kadang-kadang kalau guna centrifugal pump masih lagi terbaik lah menggunakan centrifugal pump kerana dia low cost dan sebagainya, maintenance pun mudah. Tetapi awak tetap akan ada masalah, kemungkinan awak kena buka centrifugal pump awak kerana ada daun-daun yang tersangkut, ada ranting yang halus yang termasuk, kalau ada kolam awak ada pokok lah, okay, ataupun ada batu-batu dan sebagainya. Kerana selalunya kalau kolam ikan koi ni dia akan terdedah dengan banyak faktor. Mungkin awak ada pasir, ada tanam pokok dalam kolam dan sebagainya untuk cantikkan pokok. Jadi semua tu akan disedut oleh aliran air sebenarnya. Okay, dan bahan buangan ikan juga lama-lama akan menyebabkan aliran itu slurry. Awak dapati bahawa di dalam filter awak air dah mula keruh disebabkan oleh bahan buangan ikan, dan menyebabkan kadang-kadang pump awak akan stuck. Maknanya bilah awak tu mudah terberhenti kerana ada benda asing yang terselit di antara blade dan juga casing. So that's why apa nama tu, centrifugal pump, dia tidak sesuai, it's not good, it's not suitable to flow liquid containing solid. Okay. Some type of positive displacement pump, such as a peristaltic pump and diaphragm pump, are inherently sealless, requiring no shaft seal and having zero product leakage. Okay, kadang-kala kita memerlukan keadaan di mana kita tidak mahu cecair cecair bersentuhan terlalu banyak dengan parts pump kita, kerana ia mengelakkan berlakunya contaminant. So yang paling mudah sekali kita kata kita akan gunakan positive displacement pump. We will use positive displacement pump in dialysis machine. So awak tahu orang yang buat dialysis, blood dialysis, so we need to take out their blood, flow it into a machine and then return back to human body. So we need to create a situation where there are less contact between mechanical parts and blood. So if you put that blood into the centrifugal pump, so it will touch the blade, they will touch the seal, they will touch the bearing, and so on and so forth. And for sure the shaft and the blades, they will have a lubrication. They will have some kind of seal, and so we don't know what happened on that. So because normally centrifugal pump cannot be not easily every time when you run a system, so you need to it is not easily for you to open the casing, to change the blade, to clean the blade, and so on and so forth. So jadi awak boleh faham, walaupun maintenance cost centrifugal pump adalah mudah, tetapi bukanlah tiap-tiap hari awak kena buka casing pump. Dia satu kerja lain nak buka tu. Kerana setiap awak faham, casing pump perlukan pressure tight. Kita pun belajar dalam fluid mekanik 1 dan 2, casing centrifugal pump amat penting kerana dia yang develop pressure. Tak boleh bocor. Okay, so jadi dia bukanlah kerja yang mudah untuk buka dan pasang setiap kali. Okay, so kalau untuk dialysis, kita akan ada contoh nanti di bawah. So kita akan masukkan di dalam satu pump yang mempunyai satu tube seperti ini. So darah akan masuk dan di sini darah akan keluar. So di sini kita akan gerakkan dia. So kita ada bentuk segitiga kat sini. So bentuk segitiga ni akan berputar dengan certain speed. So dia akan menyebabkan darah itu mengalir secara volumetric. So jadi dia termasuk di dalam idea positive displacement pump. Kerana dalam keadaan ini kita dapati bahawa darah hanya bersentuhan dengan saluran ini sahaja. Oleh itu tidak ada, kita kata kita lihat kurang contamination yang berlaku. Maknanya setiap kali sakit yang guna, kita hanya boleh menggantikan saluran darah ini sahaja. Okay, so boleh So and then the last one is positive displacement pump are suitable to pumping liquid containing gases. So dia juga boleh digunakan untuk mengalirkan liquid yang mengandungi gas. Kerana kalau centrifugal pump yang kita gunakan, if we use centrifugal pump, the gases inside the liquid is actually could create impingement, means it could create an erosion wear. So the gas will hit the blade and the blade will start to wear and tear, and it will lead to the catastrophic failure. Catastrophic failure ni maksudnya kita khawatir kekuatan blade tu akan menurun disebabkan ada pit yang berlaku, ada hentaman yang berlaku, dan akhirnya kita takut waktu dia pusing tu patah. Bila dia patah, boleh menyebabkan dia tercabut dan sebagainya lah. Banyak kerana dia first alignment dia dah lari, dia berpusing, dia dengan RPM yang tinggi menyebabkan keseluruhan blade boleh tercabut sebenarnya. Tetapi untuk pump yang kecil-kecil mungkin tidak menjadi masalah. Kalau untuk menyebabkan pump yang besar, selalunya dia akan memberi masalah yang besar.